We're live. I'm drinking coffee in a thermos flask, no less. That way I don't drink loads of it at once and it doesn't go cold. So I'm going to be hacking away at some domain-specific language implementation for my .NET Core WPF application. So I'm building an application to control lights that, hang on, are like this. So you've probably seen these in nightclubs, kind of moving about, shaking about, wobbling and everything. Woo! Changing colours, having patterns. They're pretty common. They're in theatres, they're in nightclubs, fancy wine bars, and they're controlled using something called DMX. I'm trying to build a system to control these, but not just like control one, but to control an entire venue's worth. So you can kind of sit at a lighting console, that's what we call them, and you'll have faders and buttons and you'll be able to bash around. And part of that is having a syntax. So a command line syntax that you can sit there and bash in to control the lights. They're also called fixtures. I don't know why they're called fixtures. Fixtures and fittings, maybe? Who knows? But yeah, the idea is a custom command line which will allow people to control those. I've gone as far. Dun, 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 dun. I mean, it is literally falling to bits. This is very, very hacked together because I do not know electronics. So the idea of building or designing a PCB is futile. It'll take me ages to learn. It's something I probably should outsource, but this is meant to be a hobby and I'm meant to be learning. So nonetheless, I'm soldering. And there's like a shed load of diodes and stuff. But the idea is that we can tap away, bump, 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 bump. It gets interpreted by the console and then turned into actions that can control those lights. So yeah, there's this is kind of based on another lighting control system called the Hog, but I don't want to stick with the Hog. I want to change things up, and I want to have a syntax that's more similar to another control system called the Graname. So before we jump straight into playing around with the syntax, why don't we have a look at where we're kind of at the moment? To do that, I think we'll probably let's share the screen. Double check that that's yeah, that's working. So here we go. I've launched the application. As I say, this is WPF .NET Core 3.1, I think 3.0, 3.1, one of the two. And it's using a couple of technologies like Apache Ignite for distributed compute and data storage. It's got Prism for the UI. And for the command line, it's got Antler. So we'll control some virtual lights to start off with. So we'll load up. This is some visualization software from a company in Sweden. It's basically one of the applications that a professional lighting designer or lighting programmer may use to pre-visualize their show. So we're going to use this to pre-visualize, not even pre-visualize, but just to visualize what we're actually doing. And at some point I'll plug that puppy in and we'll see some real lights. So I'm going to turn on some output, streaming ACN. I mean, this is all irrelevant to what we're actually going to be doing today. I just need to get the console set up so that you can see the command line in action. Oh, no, we want Martin Max 700. These are different types of lights. Different types of lights have different parameters for controlling them in different orders, and there's no standard. It's all a big mess, which is why it's such a challenge. Excuse me, very gassy today, but thankfully only from this hole. Right, so we've patched some fixtures. They've turned off because they're now getting the default values, which is to basically tell it to point up or straight down. So 50-50 on the pan and tilt, and then turn the lamp off. But with the command line, we can do 1 through 10 and then set a value, 100, so 100%, and the lights turn on. And there's a default fade of a couple of seconds, and then we can clear that out and we can just say, okay, I want fixture 8 at 100, which is just on the singer. I can do 1 through, is it 1 through 4 or 1 through 6? Let's do 1 through 6 at 25. Oh, I didn't want 6. Let's turn that off. You didn't see that. So there's 5 fixtures on the back. Cool. Let's do 1 through 5. Gobo 1 at 25. And there we go. We can change the pattern. Gobo just stands for graphical object blackout. So it's just like a metal disc or a glass disc that slides in front of the beam and obviously bounces back the majority of the light. And they're on wheels and they have loads of different patterns. So if we do, let's do 1 through 5, Gobo 1 at 15. That didn't work. 1 through 5, Gobo 1 at 15. Oh, why are you not working? Clear, clear. Ho 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 ho. Oh, Gobo 1 at 15. 1 through 5 at 100. It's not clearing the gobo. How bizarre. Is it clearing the gobo? No, it is clearing the gobo. 1 through 5, gobo 1 at, let's do like 25, maybe. Huh? Oh, I'm getting very confused now. Gobo 1 at 10. Okay, so there is... Oh, I'm sweating so much! There is stuff... there's stuff working, and there's gobos, and we can change the colour as well, and we can also do stuff like 1 through 5 tilts at 0, and move them up to the top. 1 through 5 tilt at 50, 25? No? No, no. Computer says no. But you get the idea. And if I clear that back, clear 1 through 5 at 100, they should be pointing down, but they're not. That doesn't work. But you hopefully get the idea that I'm trying to update this nonsense, blah blah blah, to something slightly different. So that syntax that I'm typing in there is based on a lighting console called the Hog. It's one of my favourites, but there's basically every other manufacturer has copied the Hog. So any console you go to will have a pretty similar syntax, apart from the Grand MA 3 or the Grand MA anything. Let's have a look. Do I have it? I mean, I've got their docs open. Do I have anything? Anything? No. Right. Let's Google then. Grand MA. Grand MA. Lighting. Here we go. So most people are using version 2. But version 3 has been released. And it's the most popular lighting console for massive shows. And that's in part because it's a distributed system, so it can scale up much larger than most lighting control systems, which is in part why my console is also a distributed system. But the syntax, the way that this works, is vastly different to that of the Hog or Chances or any of the other consoles, and it's quite different to this. You know, 1 through 5 are quite different. So what I'm going to be doing... Ooh, why are you not closing? There we go. What I'm going to be doing is going through their documentation and in Visual Studio Code, checking if my language definition works. So let me talk through how am I actually building this language, or this domain-specific language for .NET, and that's occurring through a utility called Antler. Now I'm using version 4 of Antler. Here we go. Beautiful. So Antler, another tool for language recognition, is a powerful parser generator for reading, processing, executing, or translating structured text or binary files. It's widely used to build languages, tools, and frameworks. So the idea is I can define my language, and it could be, I could be defining C#, for example, or JSON as a language, or English, or SQL. English is probably going to be a tad more difficult, especially given the sentence structure is so so loose. There's no real spec, is there, for English? But for a more fixed language, it's certainly easier. And in this case, I'm creating my own language derived from the language that MA have implemented on their control system. So what I do is I create a grammar file, and I pass that into Antler, and it will generate for me the C# code required for tokenizing, parsing, tokenizing, and yeah, just walking through the tree that it generates from the input, which is really nice. So what I end up with is just a boatload of methods that I can override. So if I come into the command line, look at all this Antler generated nonsense. You can see this is an auto-generated class, but I can override these. So exit attribute mask, exit add, or exit plus. So that means that as I'm exiting that particular node on the tree, I can execute the code within this method. So it's a really nice way to quickly build up your domain-specific language. But it all kind of relates into this grammar file. Now, I'm not using Visual Studio PC, or I like to call it Visual Studio Beast, because it's a beast of a project or solution, application, whatever you want to call it. I'm using Visual Studio Code. There's a really nice extension which allows me to debug my language definition, and I get to see the parse tree, and I can look at really nice things like the call graph and see, you know, how are things connected to each other. Look at that helping. What's this one? Objects goes to source list. If I hover over source list, yeah, it's pretty interesting to be able to get these kind of insights. Yeah, it's not something you get within Visual Studio on PC, as far as I know. You can see, you know, it's not the simplest of syntax to implement. But let's have a look at how I'm doing it. So basically with Antler, like anything, it's building a tree. So we have to have a start, and we're going to be dropping down into our different branches or our nodes. And we define our start point, and then we can just match to things. So I've got my Lexa rules here, and I've defined a couple of things. So for the MA, if we have a look at their beautiful documentation, and that's said with my tongue firmly planted in my cheek. I'm not a big fan of their docs. Really not a big fan. The basic syntax is as follows: function, object. Very helpful. So we have these objects and we have these functions, and they've got a list of them because they're helpful like that. So we have a list of object keywords. So then I can say within Antler, my objects, here we go, I need to match to the same keywords, and then the same goes for function. So anytime it comes across freeze, for example, it then understands that this is a function, and we can then, in fact, let's do that. If I type in function into our input text, I'll explain what this is in a tickety-boo. We'll go to debugging. That's not worked. What else is a function? I didn't want to do that. Oh, it's all gone Pete Tong. Oh, it's all gone Pete Tong. Where on earth is that gone? Found it. Found it. We're all good. We're all good. No. Oh, it's disaster. Disaster. Yes, right. So, what? Ooh, the sun. Function. So yes, if we did acceleration, hopefully. And now if we go to debug, come on. There we go. So we can see that this is a function. Now there are some things in MA that are both a function and an object, depending on the context. It becomes quite difficult at that point. So they have these helping keywords that can be a mixture of things. And one of those includes the @. And the @ in my head should always just be a function, because you're going to be setting a value on the object that came before it. But it doesn't work like that. Of course not. So what I'm going to be doing is slowly but surely working through the keywords here and kind of getting a feel for what works and what doesn't. Because they have some example syntax, and I'm going to be testing that against my grammar file, and where I need to and where I can see it's quick and easy, I will be updating the grammar file to make a fix for the syntax that doesn't work. So I'm going to skip past kind of these. I'll start with probably absolute. So absolute appears to be able to be a function, but it can also be a value type, because here we're doing attribute color RGBR at absolute 10, which just means that we're going to, rather than set a percentage value of 10, so 10%, which would map on an 8-bit channel to 25.5, we're going to set the DMX value to just be 10. So let's copy that, paste it into my inputs. And the reason I've got this inputs.txt is I have, somewhere in here, I have the configuration so that I can debug Antler, and it's going to look within this input.txt for the text that it's going to debug. So let's see what that does, and straight away we can see the parse tree here is updated. And I can zoom in, and I can see that we have objects, which is attribute, and then we're matching to this wildcard, which is just text and color RGBR. And then the function is @, and then arguments absolute 10. So I would say that that is working well enough for me to be able to parse within C#, or handle within C#, I should say. But absolute is not working, because to set the layer to absolute type, I have no idea what that means. What are layers within the context of MA? Who knows? But with that, I'd imagine that acceleration also isn't going to match. Oh, it does! So acceleration is a function. Well then surely absolute can also be a function. So let's try adding it here, absolute. And now absolute is always overlapped by the token function. See, this is warning me then that I've got problems. I always knew I had problems, man. And that's because it's matched down. Where is it? Here we go. Absolute. It's So where is that then referenced? Let's have a look. So in our value type, yeah, because it is a value type. When we're using it in this context, that is absolutely a value type. I wouldn't ever say that that's a function, but it should. Oh. Moving on, I'll come back to that one. I just want to kind of get a feel for how much of the syntax works with this rough draft of the grammar definition. And if it's none of it, then I will have to start from scratch. But some of it seems to be working. So at acceleration 70, yeah, I don't like that that's a function. Why is acceleration a function? It should be a value type, but it's not, because didn't I just add that to? I think I added it to here, didn't I? But it shouldn't. Let's remove it. Arguments. But now it hasn't got. Ooh, let's acceleration. Oh, acceleration. Okie dokie, picking a pokey. Something I say quite a lot, actually. It's a fun thing to say. Okie dokie, picking a pokey. Right, acceleration. Let's. Well, hey, value type. Now that makes more sense to me. But if we just then did acceleration, it has to be the same. It doesn't drop everything to lowercase, which is good because then the wildcards would be dropped on it. That doesn't work. Okay, moving on. Align. Let's see what align does. I don't think that's going to work. Do I even have a line defined? Half the problem, and it's more than half the problem, is that they have this wonderful documentation here, which is the object keywords and the function keywords. But it's not all the words. Definitely not all the words. And if shouldn't be a function because it's actually a helping keyword. So we have these words that can be multiple things within, depending on the context in which they're used, which makes it a real pain to implement this this syntax or this language. If anybody knows how to deal with that in Antler, then please ping me. I mean, I'm kind of fudging it a little. I'm going to eat. Here we go. Helping keywords. So this is my little hack in order to deal with that. And it kind of works, I think, because then it allows me to do stuff like 1 at 50, which is pretty standard. You saw me, you know, typing 1 through 10 at 50 or at 100, and it was working. And then I know that this is a function, the at 50. I just don't know that the at is the function, right? I know that I'm in a function, and I can check what I'm doing. Let's do a sign, and then we'll move on to. Oh, I know these points don't work. See, the 1.402. I don't like that, but this should work, assuming I have appearance. Do I have appearance? I don't think I do. Oh, I do! Appearance is an object. So we've got our function of a sign. I can change this to horizontal as well if that's a bit clearer. So you can go assign appearance 1 at group 5. You can see the tree. And when I'm executing this with the C# overrides, I can pick which method I want to override. So I can override when I enter a number. I can override when I enter an object, or I can override when I enter this assign, or I can override when I hit a function. And so what I do is I try and override fairly high up the tree, and then drill down within the children of the context that I've been given. So I'd be given this function, and it would have the assign. Hang on, let's make this clearer for me. Dun, 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 dun. Yeah, so I'd come into this function, and I'd be able to check its children, which would be 1, which would be arguments, and then I'd check the arguments to see how many children does that have, and then match. Okay, it's the first one is an appearance, so I can then go and have a look within my appearance table with ID of 1. I've then got an instance of that object ready to apply and pass into my next function, which would be at. So I'd be setting a value, in this case, from group 5. So I've then got to go and look up group 5. So it's there's a lot going on, I think, but that seems to have passed that correctly, which is cool. We'll save that and we'll debug. Okay, that's also working. Function and function. Super duper. Let's test out at. So we've got executor 1 at 30. Oh, executor 1 at 30. Save. Debug. Yep, that's working. One of the things that really frustrates me about the MA is that they have this at being written, and it should be that, in my opinion. So I've actually fixed that. You can see it doesn't care. It knows it's an at, and as long as I'm overriding this, it doesn't really matter what's actually coming in there. Right, because I know it's an at. So it can be at, if we run that, boom, or it can be at. It just doesn't care. And I've done that through saying this or. So when I'm defining this keyword in the Lexa rules, I'm saying it can be at or it can be at. And I could probably go as far as to say, and it can also be at. Shall we see if that works? Because again, the MA would be really fussy about that. There we go. It doesn't care. So you can write that now as lowercase as well. Super. At 75, does that work? Yes, it does. At Q3, does that work? Yes, it does. Let's do a more complicated one. Attribute pan at 20. So objects, our list of objects, and then the function which is at numeric value of 20. Now what happens if I say at 20%? Because at 20 it's inferred that it's 20%, but there we go. Look at that. It also matches there. And we had absolute earlier. Let's do absolute 10. And there we go, that also works. Cool. Let's see if the copy group for... No, I will use my at 10. Yep, that's also working. Ooh. Now let's test this API. So list attribute. Nice, that seems to be working. I mean, we've just run that, so we know it works. Off attribute 1. So it's going to knock out the first attribute, dim, on the current selection. Okay. Yeah, that seems to be working. So again, off can be either a function, in this case it is, or it can be, well, it's not really an argument, but yeah, it gets used like an argument because you're specifying 0 effectively. Let's have a look at black. Oh, I think this might be a difficult one. Black on executor 201. Ooh. Oh no, that seems to be working. Black on. Yeah, okay, I'll take that. That's a win in my eyes. Blind. Well, this. Okay, pretty simple. Just blind. I'd be surprised if that didn't work. Okay, that's cool. So I think that's going to be a toggle. Yeah, the blind is a toggle. That's cool. BPM. What have we got? At. Or you can use my at. There we go. At speed. BPM 5. So we don't have any speed. Oh, that sounded like a reference to naughty things. But it wasn't. I haven't defined speed, I guess. Speed is going to... Is speed a value type? No, because BPM is a value type of speed. Right? No? Yes? Maybe? What? Huh? Oh. Makes my brain hurt. Makes my brain hurt. Camera front. Let's see if that works. Camera front. No. Camera's not defined. Now, the frustrating thing about this is that I've copied all of the objects and all of the functions and all of the helping keywords. So that should be everything. I shouldn't be finding tokens that just don't exist. That makes no sense to me. It means their documentation is wrong. It is wrong. And that's quite frustrating. What else? I mean, we can just crack on, carry on. Let's do some cues, because cues are quite important in the context of lighting control. In that you create a look on stage, so your lights pointing in different directions, looking all beautiful, and then you record them as a cue. So what's this? Cue is an object type holding a look on stage. Okay, that's pretty clear. I like that. For more information, what's this? Cues are arranged in sequences and divided into parts. Well, that kind of... So I guess in another console, that would be a cue list. So you'd have a list of cues, but in their case, they're calling a list of cues a sequence, which is fine. I guess that's more like synthesizers. Cool. So let's try Q3. Hurrah! Store sequence 5 Q2. So that's going to be saving into effectively cue list 5 in the second queue. Yeah, that works. And let's try delete Q2. I wonder, when you type in delete Q2, which sequence? In the selected sequence. Okay, that makes sense. That makes sense. It even says it. It even says it. I just need to read the docs. What else should we look at? Fixture. Should we see if fixture stuff works? Fixture 2. Well, surely fixture 2 is going to work. Fixture. I mean, it actually shouldn't matter. If I type in fixture 2, that should be fine because it removes all the white space anyway. See, I could type this all in as one. I could be... in fact, let's take a nice look. What did we have earlier? Let's do 1 through 5. No spaces, that's the whole point of this, Mr. James. 1 through 5, attribute, pan, at, absolute, 50. Didn't work! It's the 1 through 5 that didn't work. Interesting. What if I just did 1? Oh, I know why that didn't work. I know why that didn't work. Because through needs to be defined like that. No, it doesn't. No, it doesn't. It still doesn't work. Ooh, okay. So it works if I just select the 1 fixture. But you get the idea anyway. The point was to demonstrate that it doesn't matter if I've got the spacing in. It's just kind of hardwired into me that I need to press space occasionally. But yeah, so the idea is that I can go through and I can define my grammar file and then I can use the command line to generate the C# code for me, and then that generates something. Here we go. This go to definition. This partial class, which is it's called Light Mic, but that's because that's what the project was called ages ago when I started. I really shouldn't eat and stream. Terribly rude of me. It's quite a delicious little snack from Starbucks. And it goes to a good cause as well. What does it go to? I remember reading and thinking, yes, I wish to support this, which is why I bought it. Mermaid, Starbucks. Ooh. Pink news. What's this? What's this? Oh, I'm digressing. I'm digressing. This is not good. Oh, crikey, look at those. Anyway, I think it's something to do with people that are struggling with their sexuality. There's a charity in Britain and some money goes towards it. So if you buy the mermaid stuff, you're supporting people who struggle. And that's always good. We should always help others when and where we can. Right, lecture over. Oh, the sun! Away with you! Right. So we have this Light Mic based listener. I inherit from that, and then I can go ahead and implement whatever I need. So I override like single source selection. Yes. No. Oh, I'm thinking how best to show this to you. We'll okay, well, we'll go with the single source, and we'll just whack a breakpoint in, and we'll launch the application, and I'll show you what's happening. This is horrible code, by the way. My horrible code. This is one of the bits of the application that I constantly try and avoid. I bought a book, Language Implementation Patterns, in order to help me with this. Problem is, buying the book doesn't automatically put that knowledge inside my brain, and every time I try and read it, I just go, it's quite intense, and it's in Java as well. All the examples are in Java, so it's just close enough to look like C# that I'm like, oh, I understand that, and then I think about it a little more, and I go, no, I don't understand. Right, streaming ATN. We'll turn that puppy on. Shall we control the light? Yeah, we'll do that. Let's plug it in. So, just to be clear, hang on. Boom. NTEC ODE MX2. So the lights are controlled via DMX. The DMX specification does say it needs to be 5-pin, but because audio cables are cheaper, most shitty disco lights like that use 3-pin. So I've got this little adapter so that I can plug into my horrible cheap Amazon purchased light. But what I sent to this is an Ethernet based protocol. It's on UDP, or it's a UDP protocol, where I'm just streaming some data at it, and then it translates that into I think it's based on RS-232 or RS-485, I do forget, but it's a serial based protocol which the light can understand. So we'll plug in the data, and we'll plug in the power. How exciting. Right, now this is the B topper. And it's going to check all of its. Can you see this? Yes, it's there in the corner, isn't it? Woo! Right, we'll patch just the one. There we go. It's gone to its home position. And now I've got the breakpoint set, so things should stop on the breakpoint. Boom! As they do. So I get my context and come in here and I can see it's got some children. So let's have a look at the children. Start is 1. Okay. And that's got a child. And that's got a child. And that's got a child. Lots of children. And this is kind of the frustrating thing about Antler, is that everything's kind of nested into these children. But you can see the input stream. You can see where you are along that input. And you can see what token it's matched with. So that it's super powerful, but I don't write the best code for Antler, and so my code kind of ends up a bit shit. But let's remove that, and then we should be turning that puppy on. There we go. Let's turn it. 1 tan at. Let's do 30. Oh, that worked. 1 tilt at 15. 1 color 1 at 10. That's gone blue. Is this obvious? Is it obvious it's gone blue? Yes, you can kind of see it behind me. Very good. And then we can do 1 color 1 at 30. Pink. So what's actually happening there? So I'm parsing in this source listener, and let's pop a breakpoint there. We'll pop a breakpoint there. Exit command. So we can see that we're actually, we'll pop a breakpoint there, and then we will put a breakpoint there. So a lot of breakpoints. But now we'll do the same thing. So we'll just do 1 at 0. So we want to turn the light off. So straight away we've fallen into our first breakpoint, which is a default command, which is select fixture local command. So the whole system is running on command. So if we pick this definition, this implements iCommand, which has execute, redo, and undo, or undo and redo. And that then calls into another service that's deployed. So there's lots of little microservices for all of this. And that, depending on which editor I've got selected, depends on what we're knocking out or putting into. In this case, it's the programmer. So Lighting consoles work on a priority-based system. I don't really want to get into the ins and outs of how control systems work. But regardless, I'm creating a command based on the selection, because we've got source, command, destination. That's the way that the current syntax for the console works. It's completely changing with the new grammar file that I'm working on. So that was the source. This is a command, and as we're exiting that command node or on the tree, we fall into this method here, and I have the context, and I'm checking here. Does the command, or does the text match at to define that it's that I'm going to be adding a value after that? If it is, and I say command type equals command at, and then if I continue, we finally get down to this composite local commands. Composite local commands just allows me to add multiple commands into one. Otherwise, in the log, and I've got the logger running on syslog. It just gets kind of spammed full of loads of commands when the user's actually only typed in one thing. So I use this composite local command to hide lists of commands. But we've got a selection, so select fixture local command, and then we have a set feature to percentage value console command. The naming is all whack, but it works nonetheless. So with that, it then executes and the light turns off, and I'll disable the breakpoints, and then we'll do 1 at 100, and it should turn back on. Perfect. And it's turned back on into pink or purple, whatever that is, because we didn't clear out any values. If I clear the values, it's going to turn off and the light is actually going to move. So boom, the light will have gone back to its home position. If I turn it on again, 1 at 100, let's move it so you can see it. 1 pan at, what was it, like 25, 30? 30 will do. 1 tilt at 30. Definitely less than 31. Tilt at 20. Yeah, that will do. It's now white. I can do 1, go over 1 at 15. And we can put patterns in it. 1, go over 1 at 20. There we go. Yeah, so this kind of way of building the language and then having it generate these classes for me, which I can then override, is really quite nice. The difficulty is just making sure that it's matching to the right nodes. So I want to have, for example, when I exit function. So when I finish processing all of this, I'll put that into a method, for example. Or I might want to have objects. So when I exit an object, and every time it finds an object, it will execute code within there. The reason I do that is I don't want to be overriding the lowest kind of leaf on the branch. I want to be a little bit higher up the tree. So in this case, I'd override the arguments, and I would have a look to see how many children does it have. It should really only have 1 or 2. If it's got 1, I know the argument is just going to probably be a number. If it's got 2, then it's probably going to be a value type and then a number. So it might be, for example, group 5. But group's actually going to be an object rather than a value type. But you get the idea. There would be 2 children of argument. So within my exit arguments, I would count the children, check the first child, know that it's an absolute value, and then check the second child, and then I would create a command within the console, and there's loads of commands. So if we come to, here we go, like console.core, we've got this set feature to absolute value. So that's what we would be calling here, and we'd be passing in the attribute and the value, and then a fade time. There's a default fade time of a couple of seconds at the moment, but that can be set in the user preferences. And then that calls off to, in this case, the programmer service. And the programmer service, I mean, let's look at the definition for that. I mean, there's quite a lot to this project. There's a lot of code. Just over 25,000 lines of code at the moment. So it can become a bit of a difficult mess to find where anything is. But here within the program we have select. So when we call those select fixture commands, it ultimately, depending on which editor is selected, in this case it's the programmer, it would call into this method here. Obviously it's private because we expose a list, and then from there we loop through. Deselect, knockout, touch, suck, rendim. So some of these aren't implemented, but I've at least listed what they're actually going to do, so that when I'm struggling to like, why did I put that in there, I can actually come and have a look. And then The set feature value is quite a cool one. So this is kind of where the magic happens. So we loop through the selected fixtures, so the selected lights. We check, in this case when we're setting the gobo, for example, we check out of the selected lights which one of these lights has a gobo. And then once we've found those matched fixtures, we'll loop through them. We'll look for the channel that has the gobo, because obviously if I've got another light that isn't a B-topper TLS 10K, the gobo channel might be on a different, well, it could be different. It might not be offset by 2, it might be an offset of 6. So I have to allow for that, and then I've got some code for dealing with different types of 8-bit or 16-bit channels. This is totally a hack. This was from the last time I was playing around with this. In order to get the pan and tilt to work properly, I've been thinking about how best to change that, but it is irrelevant to the language stuff that we're doing right now. So yeah, the biggest thing about Antler that is marginally frustrating is the fact that it runs on Java. So the SDK that I've installed within the project doesn't have Java. It's just a NuGet package. You can come in and search for Antler 4. Oh, Antler 4. And you can just bring in the runtime. So that way it's just pure C#, and it's going to take the code that's been generated, and it's going to allow you to interpret that. If you want to generate code, if you want to generate that C#, you need to have Java installed in order to actually run Antler itself. That's clear. I didn't want to do that. I'll wait for that to finish. I've written some docs on. I mean, this project is both on GitHub and on Azure DevOps. Both private, I'm afraid. But I've written some documentation in the wiki in order so that when I come back to this, I'm like, how on earth do I update that? Then I can very quickly have a look. So I can just come in and copy and paste this stuff. But it's pretty simple. I've got Antler 4, which is not recognized because I actually need to copy and paste this. Didn't want to do that. Boom. And now when I do it Antler 4, it should work. Well, hey, some reason when I set this stuff is environment variables and to try and keep it permanently, it doesn't work. Who knows? I'm new to Windows, newish. Yeah, and then I can point it at my grammar file, which is at the G4, in this case, this puppy. And then I can say Java C. So why don't we do this? Let's do it. Right, let's reveal in File Explorer. And we'll go to desktop. Let's create a new directory and we'll call it demo. No. There we go. Demo. And we'll copy that puppy. And we'll CD into there and we'll clear that out. Now let's bring up the docs. So it's going to be Antler 4, and then it should just be light console.g4. So with any luck, no luck. Antler 4. Why are you not working? Let's have another look. What am I doing wrong? Right, we'll start from the top. I truly find Windows very confusing. Why Why is that not working now? Oh, for crumb's sake. Right. Now, do less continual. I don't think I need the test rig. But I do. Diddly-doo-doo-doo-doo-doo. On this puppy. Come now. Come now. Maybe it's just because I'm not specifying O. Let's try that. See, I had this problem before. And it drives me nuts! It honestly drives me absolutely crazy. Is it because I've got down? Do I need to remove the quotations? Ah! Ugh. You may be wondering, Mike, why aren't you using the new Windows terminal? Because it's even worse. It's even worse. Oh. Right, let's see. Still nothing. Oh. Well, it's meant to bloody work, but it doesn't. So you'll just have to maybe trust me, or maybe you won't. I'd understand if you didn't. Oh, it's so frustrating. Honestly, Antler is the thing that just makes me want to throw my computer out of the window. To get it set up is frustrating. To get Java installed, and it's like, oh no, you've got the wrong version of Java installed. I can't run. It's like, how do people work like this? The idea is that when you run this Antler 4 and pass in your grammar file, it should then produce for you some Java. You can then run the Java C command, which is then going to compile anything that ends in .java. I'll actually get rid of that like bit. You just anything that its producer ends in Java, you want to compile, and then you can run Antler 4. And then in this case, we're specifying the language that we want to output. In this case, C#, and then the path to save, and then again the grammar file. When it doesn't work, as I say, I just want to throw my computer out of the window because it's like, give me an error message, give me something. But it gives you nothing of any value. But when it does work, it's wonderful because it saves you so much time. But when it doesn't work, so yeah, so this is Antler, and I'm just going to carry on trying to understand what the chuff is going on with this darned, that's very irritating, darned API. The syntax from MA that makes very little sense to me. Right. Help. That's what I need. Actually, I wonder. Help F. Ooh. The wildcard. Wildcard. So I don't think help's in their list of. Oh, it is. It's a function. Help is a function. Why? Okay. No, that makes sense. That makes sense. Crikey, look at that. That definitely isn't going to work. So the @ symbol is then defining, I guess, a directory. So that's then going to break the fact that I've said I want my @ symbol to... Let's see. This is definitely going to break. Yeah, look at that. Helping @ They should have specified that they're using that symbol, but they haven't. You just got to read their docs and be like, oh, okay, so they are actually using that. What is the point in documentation if it's not correct? It's just frustrating. It's just frustrating. Right. I'm gonna carry on. Yeah. But I'm going to do it privately because no one needs to see me shouting at my computer. And I've got more mermaid to nibble on. So thank you for watching. Hopefully some of this has been useful. If nothing else, it's good for me to be able to come back and look at me frustrating or being frustrated at numerous things in a little while. Yeah, right. Enjoy your days and toodle pip. Right, now I need to stop.